Welcome to Academic Gain Tutorials. In today's class we are going to learn in details about processing operations and assembly operations. We are studying Introduction and Overview of Manufacturing. We will cover all related topics one by one. Before starting, if you haven't subscribed to this channel yet, just click on subscribe and press the bell icon. Here, we come up with new videos on different subjects to make the academic studies easier for you. So, into the topic. Processing operations. A processing operation uses energy to alter a work part's shape, physical properties, or appearance to add value to the material. The forms of energy include mechanical, thermal, electrical, and chemical. The energy is applied in a controlled way by means of machinery and tooling. Human energy may also be required, but the human workers are generally employed to control the machines, oversee the operations, and load and unload parts before and after each cycle of operation. A general model of a processing operation is illustrated in this figure. Material is fed into the process, energy is applied by the machinery and tooling to transform the material, and the completed work part exits the process. Most production operations produce waste or scrap, either as a natural aspect of the process, for example, removing material as in machining, or in the form of occasional defective pieces. It is an important objective in manufacturing to reduce waste in either of these forms. More than one processing operation is usually required to transform the starting material into final form. The operations are performed in the particular sequence required to achieve the geometry and condition defined by the design specification. Three categories of processing operations are distinguished: shaping operations, property-enhancing operations, and surface processing operations. The shaping operations alter the geometry of the starting work material by various methods. Common shaping processes include casting, forging, and machining. Property-enhancing operations add value to the material by improving its physical properties without changing its shape. Heat treatment is the most common example. Surface processing operations are performed to clean, treat, coat, or deposit material onto the exterior surface of the work. Common examples of coating are plating and painting. Shaping processes. Most shape processing operations apply heat, mechanical force, or a combination of these to effect a change in geometry of the work material. There are various ways to classify the shaping processes. The classification used in this class is based on the state of the starting material, by which there are four categories. Solidification processes, in which the starting material is a heated liquid or semi-fluid that cools and solidifies to form the part geometry. Particulate processing, in which the starting material is a powder, and the powders are formed and heated into the desired geometry. Deformation processes, in which the starting material is a ductile solid, commonly metal, that is deformed to shape the part, and material removal processes, in which the starting material is a solid, ductile or brittle, from which material is removed so that the resulting part has the desired geometry. In the first category, the starting material is heated sufficiently to transform it into a liquid or highly plastic, semi-fluid, state. Nearly all materials can be processed in this way. Metals, ceramic glasses, and plastics can all be heated to sufficiently high temperatures to convert them into liquids. With the material in a liquid or semi-fluid form, it can be poured or otherwise forced to flow into a mold cavity and allowed to solidify, thus taking a solid shape that is the same as the cavity. Most processes that operate this way are called casting or molding. Casting is the name used for metals, and molding is the common term used for plastics. This category of shaping process is depicted in this figure. In particulate processing, the starting materials are powders of metals or ceramics. Although these two materials are quite different, the processes to shape them in particulate processing are quite similar. The common technique in powder metallurgy involves pressing and sintering, illustrated in this figure, in which the powders are first squeezed into a die cavity under high pressure and then heated to bond the individual particles together. In the deformation processes, the starting work part is shaped by the application of forces that exceed the yield strength of the material. For the material to be formed in this way, it must be sufficiently ductile to avoid fracture during deformation. To increase ductility, and for other reasons, the work material is often heated before forming to a temperature below the melting point. Deformation processes are associated most closely with metal working and include operations such as forging and extrusion, shown in this figure. Also included within the deformation processes category is sheet metal working, which involves bending, forming, and shearing operations performed on starting blanks and strips of sheet metal. Several sheet metal parts, called stampings because they are made on a stamping press. Material removal processes are operations that remove excess material from the starting workpiece so that the resulting shape is the desired geometry. The most important processes in this category are machining operations such as turning, drilling, and milling, shown in this figure. These cutting operations are most commonly applied to solid metals, performed using cutting tools that are harder and stronger than the work metal. Stronger than the work metal shows a turning operation. Grinding is another common material removal process. Other processes in this category are known as non-traditional processes because they use lasers, electron beams, chemical erosion, electric discharges, and electrochemical energy to remove material rather than cutting or grinding tools. It is desirable to minimize waste and scrap in converting a starting work part into its subsequent geometry. Certain shaping processes are more efficient than others in terms of material conservation. Material removal processes, for example, machining, tend to be wasteful of material, simply by the way they work. The material removed from the starting shape is waste, at least in terms of the unit operation. Other processes, such as certain casting and molding operations, often convert close to 100% of the starting material into final product. Manufacturing processes that transform nearly all of the starting material into product and require no subsequent machining to achieve final part geometry are called net shape processes. Other processes require minimum machining to produce the final shape and are called near net shape processes. Property enhancing processes. The second major type of part processing is performed to improve mechanical or physical properties of the work material. These processes do not alter the shape of the part, except unintentionally in some cases. The most important property-enhancing processes involve heat treatments, which include various annealing and strengthening processes for metals and glasses. Sintering of powdered metals is also a heat treatment that strengthens a pressed powder metal work part. Its counterpart in ceramics is called firing. Surface processing operations include cleaning, surface treatments, and coating and thin-film deposition processes. Cleaning includes both chemical and mechanical processes to remove dirt, oil, and other contaminants from the surface. Surface treatments include mechanical working such as shot peening and sandblasting, and physical processes such as diffusion and ion implantation. Coating and thin film deposition processes apply a coating of material to the exterior surface of the work part. Common coating processes include electroplating, anodizing of aluminum, organic coating, collet painting, and porcelain enameling. Thin film deposition processes include physical vapor deposition and chemical vapor deposition to form extremely thin coatings of various substances. Several surface processing operations have been adapted to fabricate semiconductor materials into integrated circuits for microelectronics. These processes include chemical vapor deposition, physical vapor deposition, and oxidation. They are applied to very localized areas on the surface of a thin wafer of silicon, or other semiconductor material, to create the microscopic circuit. So, till now we have been discussing the processing operations. Now let's learn about the assembly operations. The second basic type of manufacturing operation is assembly, in which two or more separate parts are joined to form a new entity. Components of the new entity are connected either permanently or semi-permanently. Permanent joining processes include welding, brazing, soldering, and adhesive bonding. They form a joint between components that cannot be easily disconnected. Certain mechanical assembly methods are available to fasten two or more parts together in a joint that can be conveniently disassembled. The use of screws, bolts, and other threaded fasteners are important traditional methods in this category. Other mechanical assembly techniques form a more permanent connection. These include rivets, press fitting, and expansion fits. Special joining and fastening methods are used in the assembly of electronic products. Some of the methods are identical to or are adaptations of the preceding processes. For example, soldering. Electronics assembly is concerned primarily with the assembly of components such as integrated circuit packages to printed circuit boards to produce the complex circuits used in so many of today's products. So, we have studied in details about processing operations and assembly operations. Thank you.